Good evening, everyone. Mechanics of Materials, Chapter 10, Strain Transformation. In this problem, we have a solid steel bar which handling a tensile force of F in the z direction. And if the ratio of volume expansion to decrease in area is equal to negative 3/4, we want to calculate the Poisson ratio nu. So we remember that volume strain is equal to epsilon V, and epsilon V is equal to E, and that's summation of epsilon x plus epsilon y plus epsilon z. And from the equation, epsilon V is 1 minus 2 nu over E times summation of sigma x plus sigma y plus sigma z. And we already know our sigma, and also areal strain is epsilon A, comes from this equation, and that's nothing but epsilon x plus epsilon y. We already know that sigma x and sigma y are equal to 0. Sigma x and sigma y, there is no stress on that part. And in z direction, we have force applied to the cross-sectional area of our solid bar. So that's force over the area. Do the same for epsilon a. Sigma x, sigma y is equal to 0. So we have only this part left. So by having the ratio of epsilon, if we rearrange the epsilon v and epsilon a volumetric strain and areal strain, we reach to these two equations. Then by the epsilon v over epsilon a dividing these two equations, volume strain over the areal strain, we can have like these two equations. We already simplified those two equations and reach to this part, epsilon v over epsilon a. We can also cancel out the f over a from numerator and denominator, and also modulus of elasticity from both denominator in both part, and then we left for a epsilon v volume strain over epsilon a areal strain is 1 minus 2 nu over negative 2 nu, and we already know that that's equal to negative 3/4. So if that's the case, we can simply by simply multiplying these two part, a 6 nu is equal to 4 minus 8 nu, and if you do so, it just gives us a nu equal to 2 over 7. Thank you. We'll solve more problems.